working together that, I asked her for her advice about like what's important with data analytics. And I asked her if I could send her the email that she sent me. And so we actually, with the data science course, we turned it into a lesson. And so I posted it in Canvas as well. So basically, what she says is, as a product manager, she's worked with 4 data scientists, a data director, a data intern from Flatiron School at Google. She worked with data scientists, data engineers, strategy, and ops analysts from top 3 consulting firms. Okay, general observations, right? So these are, we're spending a couple weeks on this, but these are people that have gone to school, and this is all they do every day. So everybody knows how to crunch data. Fewer people know how to draw insights from the data, right? Spot interesting patterns or tell a story about real world life from that data. Even fewer people know how to affect change with data. That means ask the right questions, pull the right data and analyze it, understand people/org in your company, right? In other words, who are the right people to talk to, present the data in a way that people care about it or would take action on it, and then continue to work with people to iterate, analyze, and take action. All right. So, then here's kind of different levels, right, of teach others in the org to be data driven. And she says, this is an executive level. And you'll be able to, read this. I don't think there's too much quite here, except for just how valuable this is. This, I think, is kind of this would be great if it is senior level. You should be able to certainly rely on a senior person to do this, but I do think certain people that have I do think it's kind of within your realm, maybe I should put it, to be able to follow through with this, right? Take a simple project request, figure out the needs, and follow through. So we might say, hey, develop a new set of goals for the sales team. So you want to talk to the different stakeholders, figure out what are the constraints, really, what are the goals, understand where the data is and what it is, right? That's kind of our checking the data set. Develop a plan to define the data, get it, vet it, and train the team on how to use it. Here, this might actually be useful too. But then here is really, this bottom part, you can see examples of specific traits sometimes seen in data analysts who are difficult to work with, meaning from a technical standpoint, right? And this is the reason why they're difficult, right? Because they don't apply the 80-20 rule. In other words, what they do instead is they go down a rabbit hole and work for days without asking for any feedback, right? So this is kind of the first, if you remember how I ended the last class, this is, and believe it or not, I had not looked at this in 2 years until today. But that's really all this first section has been about is, hey, because I do think it's very typical and almost probably how a lot of us were implicitly trained, is to develop a hypothesis and then go test it, go dig deep in it. And that's really step 3 or 4, right? Instead, what I'm advocating for is, hey, take a broad sweep of the data, look at it broadly, and then you can start to dig a little bit deeper. But this first kind of, hey, where is the low-hanging fruit? Let's take a look through it, everything, and especially, right, we built that library and used this simple group by stuff as a way to do that, right? So that's the first thing, and that's really the main takeaway. Is we talked about, do a little bit of cleaning of the data, check the representativeness of the data, and then third thing, right, take this broad sweep of the data and see where is there movement in terms of, based on these categories, how does our target change? Then the next thing is don't know how to draw insights from the data. We'll get into things like this soon. I think hopefully you can start practicing this now. But somebody asks, why are fewer students enrolling? And the data analyst replies with a long story about how they pulled their data, caveats to their data, what they've observed, but not the actual answer. I think this is very typical as well. And like in a presentation too, oftentimes you'll see, hey, here's all the work we did. But really what people are going to, I wouldn't say assume you did it properly, but they can always question, the process that you employed. But what they want to get to is, all right, what is the answer? Why are so many fewer students enrolling? What's the answer? Or like, what are 3 hypotheses? And here's why we think they're valid. 3, things that are, make them difficult to work with. They present data in ways that are not useful. For example, the sales team wants to know which leads to prioritize, but the data dashboard is a huge pivot table with many columns that don't actually sort or highlight the likely candidates, or in a presentation, the slides are full of dense numbers and not takeaways. Again, we'll move into this, like the data storytelling component, more in next, probably by Tuesday, it seems like. But yeah, like basically each chart, we're exploring the data, but for each chart, we kind of want, like, what is the conclusion or the takeaway from this? This I don't think you all would do. Assume the data is a certain way or get frustrated if the data isn't clean/perfect, right? This is more typical of people that are less technical than all of you are, right? Cool. So that was the main thing, right? So I just wanted to show you, like, even among, you can do a lot, like really add value just through essentially a lot of the components that we're going through. Like even without fancy machine learning, anything like that, you can that stuff can lead to people going down rabbit holes, whereas this, allows you to attack the right problem. Questions about this or anything before I move on? All right, then let's keep going.
Oh, so Jeff, yeah, I have a quick question.
Sure.
So sometimes like you have multiple tables, right? So like how do you like first like examine them individually or like join them like
Yeah, it's a good question. So we'll deal with a lab that works with this, that kind of poses this problem. But essentially, what I would do is, let's say we have, so we have like kind of like these multiple tables. It would be, okay, well, where's your target, right? Like if you have we know that we're going to need that data if it's like sales revenue or something like that, or the price. So that obviously we're going to need. And then generally what you might start with from there is like the join table. By that I mean like what's the table that are like transactions or the events, whatever that is that you're trying to optimize for. Okay, of all the transactions, of all the visitors to a web page, if it's something like that, these are the ones who click, sign me up, right? And then from there, you can almost think of your dimension tables. Like, right, if you have like 100 tables, it's hard to, sometimes you can, like you could, and if you are like really a data scientist working with this a while, you could probably just load a subset of the data, maybe you can join it, and then kind of, use some automation to tell you, hey, this is where we really see movement in the data. Like that's effectively what we're looking at is, as we change this, how do sales change? So there are ways to do that. You can just kind of try to load as much as possible, but to be more like directed about it, what you can do is say, okay, I can't load everything for now. So I'm going to kind of take a guess as to what are the most important tables to load. You still want to be pretty broad with this in the first pass. And what I would recommend is start with like the join table or like the event table, right? Or what we call like the fact table, as you know, and then the dimension tables, right? So if it's transactions, then we have customer data and maybe there's salespeople here, and then maybe there's the product over here, and then there's obviously like this date time stuff as well. Okay, so that's what I would recommend. And then you would join, in pandas you can join by just merging everything, right? And then you can just plot it, right? And you can select, right? You can just say, okay, we have this giant data frame, and I forget if we did this in a lab already, but if you have all these different columns, let's say you have, certain columns. Again, you want to be pretty broad, but you can say, okay, here are my customer calls. Let me just do this in text. Customer columns, and maybe that's a list of columns, and that's like the age of the customer, and let's say their income or something like that. And then all you do is say, okay, here's my df square bracket customer calls, and then take this and pass that into like our build and plot, or whatever it's called, plot and build function. Right, and then you go to the next one. So now this generates 2 plots, and then we go to the next kind of set of data for our for like our product columns, right? And we just say, okay, here's my product columns, it's the color and the cost and things like that, and then we plot them, right? And see how does the revenue break down as we change the color or as the price increases or decreases. But again, like kind of what the general idea is, let the data tell you where to look. Like one thing I think if I like taught this again, or maybe I will do this, we could remove the names of all these columns, and you could still do the analysis without knowing what any data really represents, at least that first pass, right? Because what you're looking for is just movement in the data. You're just looking for the charts to change. And so without and you're saying, I don't really know what's indicative or not of a change in the data, right? Like we could remove this, and you would just say, oh, okay, like the data is changing dramatically by whatever this thing is. It happens to be genre. But the reason why you're choosing it isn't because you know something about the genre. The reason why you're choosing it is because there's a change. You see a change in the data. Okay? From there, it could be the case that this isn't really about genre. This is about, the colors on the screen, and it just so happens that action movies have more, green colors than racing company. Like it could be the case that this is just highly correlated. We'll talk about that later, that this is highly correlated with something else. In other words, the movement in the data, it might not always be about this category, but rather something correlated with it. But that first kind of, let's look at this. And then what you do is you talk to someone, like a stakeholder, and they say, that makes no sense. Like people don't really care about the genre, they care about the colors on the page, and that's how people buy video games. And then you kind of do the analysis on that. You gather the data, verify it, etc. But this is, and that's kind of the key thing, is you don't know which one of these attributes is going to pick up on something interesting, right? And so, but you want to follow it, and it could be not exactly about the topic itself, but rather that this is picking up something else that's interesting. I don't know if that made any sense, but we will talk about correlation later on. Okay, so what we did was we basically wrote ourselves this function, right? That all we do is we select the data, make sure that this stuff's representative. Then we just call our build and print, specify some columns, and we run through, right, these plots. Okay, and what we're doing so far is we're just plotting kind of total per year, I guess, or whatever the target is. We're not. Pretty soon we're going to get into like growth rates, right? For instance, like how does action movie revenue change year over year, for example? Because that could be interesting, right? If you see it start to plateau, right, it could be the case that this, like our Marvel whatever video games aren't going to be as profitable, in the future. Okay, so that's one thing to talk about that we'll get to in a second. Before doing that, there was this danger of grouping thing. I think some of you all picked up on this actually as you were moving through some of the labs and brought it up. This is just a very kind of simple example. Is imagine we are like Walmart, right? And we're trying to figure out how does revenue break down across our various regions. And we say, hey, whoa, it's doing super well. We're doing super well in the Northeast because that consists of 65% of our revenue. And then it could be the case that 65% of the stores are in the Northeast, right? Or 65% of our marketing budget is in the Northeast. So that's really why in other words, for a bang for your buck, maybe we're not doing super well. So the whole point of this is there's a danger right? You have to be aware of the fact that we're grouping our data. And so then the question is, well, when does this really become dangerous or something to pay attention to? And it's really like when you're doing something that's not, when you're grouping above the like atomic level, and that's kind of maybe a little vague, but with retail, it might be like the store level, right? Because there's a lot of cost to starting up a store, and there's a lot of like, fixed costs and maintenance. Maybe it costs about the same amount per store, but as we have more stores, we want to see how do they do. So instead, perhaps what you'll do, if it's possible, is think about how do stores in the Northeast do? What's the average profitability of a store in the Northeast versus a store in the Southeast? Something like that, right? You can always go like more atomic than that, right? You could think about like an individual salesperson, but again, like a lot of the cost of a store isn't about the salespeople; it would be about the building maintenance as well, and things along that. So this goes into details about it. One thing to do was just think about these two metrics have become popular, right? The customer lifetime value, what is like the total amount of revenue or profit that we earn from a customer over that customer's relationship with the business, and then the cost of acquisition of the customer. What's essentially the upfront cost of getting that customer in the first place, right? So might cost you $20 to acquire the customer, and then you want to make sure that over the lifetime of your relationship with that customer that you earn over $20, right? And then you can think about that metric, like that could, lots of times it's hard to get there, but this is a good thing to like think about it, and you can apply this to even like stores. You can think about, okay, what's the customer lifetime value times by the number of customers that we're getting in this store, etc., and then how much are we spending per customer to get them. Okay, so anyway, the point is like think about the units, especially when you're collecting things above, right, that like atomic level, okay? Because you might be saying, hey, like you don't want to draw conclusions that aren't warranted. Okay. All right. So this reading, certainly do this, look through it, and hopefully it informs the way you think about this analysis. Okay, then this one, I know I'm going through these quickly, but they're basically very similar to the work you've been doing. The whole point of this power users section is to say, hey, even when you have something like very granular, right, like a customer, you can still essentially apply our analysis to it. Which, remember, our analysis was, hey, let's apply the 80-20 rule, right? Let's see like if we're doing products, what are the most valuable products, and then focus on them, right? As opposed to all of our products. Here we can do the same type of thing, right? Even though we have like thousands of customers, the whole point is, after we do this is just cleaning up the data a little bit. We can come back to that. What we're doing here is saying, okay, we will build our group by, do our build group by, and this is the percentage that each customer, right, of the total profit. Is obviously not a lot, right? But then we're adding it up for the cumulative percentage, right? Remember, this build group by gives us the running total of our target. So we can do that across basically all of our customers, and you can see that it adds up to 100% eventually. And then we can kind of do the same thing where you say, okay, let's just select those where the cumulative percentage, let's say, is greater than like 0.8. Okay, something like that. And, sorry, I didn't mean, wait, is that what I want? I think hold on, I'm going to have to look at what I did. Okay, so first I plot it. And this is kind of interesting because you can see if we plot right, the index was just the number of customers divided by the total, and then we plot the running cumulative percentage, right? you can, and we did this in Plotly, but you can do this in anything. So I just plotted the percentage of customers I'm going through against the running total of basically revenue. We can see that even just 8% of our customers account for half of our data, half of our revenue, right? So that's pretty important, right? This seems like, we can identify these users. So then here's how I finally do it. So what did I do? I think I did something similar. Basically select the users where cumulative percentage is less than 0.8. Isn't that what I just did? All right, and now what you'll see, this shape thing, I call these my power users, right? And you can just choose a cutoff based on, guessing or the graph. Like the graph can be useful, and you can, and say, okay, to get to 80% of the users, that's only 80% of the revenue, that's only 30% of the users. So then from there, you can kind of say, well, what percentage does this of power users consider, how many people are power users as opposed to just normal users? So this shape thing, that just is the dimensions of the data frame. It's the number of rows and the number of columns. So this is saying there are basically 20,000 rows and 65,000 in our power users in 2 columns, and 65,000 rows overall of customers overall, right? So 1/3 of the users consist of 80% of the revenue. All right. And then what I like to do, and here I just play with the numbers, right? I can get to 50% of the revenue with only 8% of the users, right? We know that from this graph above. And then what I like to do, what I'm doing here is I'm saying we can select, right? Let's say a user has multiple transactions. What we can do is take that original data frame of transactions and say, hey, let's just select the transactions related to our power users. And the way to do that is you can just take this index and have the index equal the power users. Oh, no, we'll do this. We'll have the index of this, just set it equal to the customer ID. Okay, and then from there, we'll get all the power users' customer IDs and pass that into Loc to just select. It's an easy way to just select the power users' IDs who match the customer ID here. So we can do that. So updated transaction df equals the customer ID. So I'm going to take this column, set it equal to the index here, and you can look at that. Right, so now it's all the customer IDs, and then basically what you'll do is you can take this power users df and say, give me all the power users, all the matching power users here, and do .loc, I think, to select them. So these are the power users customer IDs, and then we'll pass it through Loc, and this should give me, right, a subset of them. And you can confirm that by doing shape. And notice, again, it's just 1/3 of that original data. Okay, so now what have we done? We've selected the transactions, but only the transactions associated with our power users. And then from there, now we kind of have another kind of specified data set of interest. And all you need to do is pass this into our build and group by, whatever we called, I forget what it's called, print, what's it called? Build group by, and you can say, okay, what do power users look like? In other words, what products do they buy? Are they male and female? Just anything, right? Where are they from? Blah, 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 blah. And I want to see, okay, is there different behavior for this kind of special set of users that are accounting for a large percentage of my revenue that is different from my standard user, right? Because if 50% of my revenue comes from 8%, right, I want to learn a lot about that 8%. So you can see the other thing I do is I just compare it against people that are specifically not power users. I think I might have spoken about that before. And then we just take the power users and we pass them into our build and print function, and now we just plot characteristics of our power users. Okay, and then later on I see the difference with against the people that are not power users. All right, so you can do that with users and you can do that with products. It's essentially the same process that we did before with before we found the products that were of interest, and then we just selected those transactions related to the products or whatever. And then we did that whole digging deeper by just saying, I don't know what's going on with them. Let's find out. So pass through as many columns as possible to see where are there differences in the data. How does this feel okay? Any questions or things to go through with this? Okay, cool. So again, the main point here is even when you have, right, like a lot of different like users, right, and it seems like, how do I analyze this? It's the same. It's really conceptually exactly the same, right? Just select up to a cumulative percentage of the target, 80% or whatever, and then dig deeper by using let's just select that data frame and then see how does it break down. Okay, here's the next thing. And that is, kind of like I mentioned before, what we've been analyzing so far has been, sales per year, right? But we haven't been really, or sales per person or whatever, sales per product per year. But we haven't looked at growth rates at all. And that's a pretty typical, another kind of way to take this like broad sweep of the data, right? How are we doing? And then like, what's the direction? Is this declining? Is this, right, et cetera. So what do we have? We're back to our data set of, right, our video game sales. We can see we're selecting it here. And then remember we did that whole, let's just select the representative data. So I think we said there was too few rows in 2017, and we don't want to go too far back. So this is the data that we selected between 2012 and 2016. Okay, and then like the first thing we did was we just print it, right? We pass through this stuff, we do a print, and we just look to see what's interesting. One thing that we saw, right, is obviously we saw a lot of variation among genre. Okay, so one thing we may want to do is say, what is the growth rate of different genres, right? And we could do this on other things too, like what is the growth rate of, here's some variation as well among different publishers, among games, right? Because we know these are like franchises that they keep churning out, I feel like. Okay, so how do we get to growth rates? All right, time for me to code some stuff. So we start with our selected data frame. Remember, what's the grain of the data, right? So the grain of the data is like each game, the year that it was released, our target, right, or it could have been any of these sales. So it's basically game per release year. And then we have genres that are, we could have multiple genres over the same year. So if I want to get to figure out how does a genre grow over time, right, what I could do is basically do a group by, because I want to get to the sales, let's say it's global sales of a genre per year. Let's just get there instead of global sales of an individual game. We want to go from individual game to genre. So I can group by genre, comma, year, and then do a sum, and then this will give me all of them. Let's just say we just want global sales. So I'll do this. I want to keep it a data frame. That's why I'm doing this pass through a list of lists. So this is global sales. Okay, and this is pretty good, right? It's complaining because it wants me to pass through only numeric columns. I forget what I need to numeric only equals true. That's fine. So now it's not complaining anymore. Okay, so we have this, and this is for each genre. How much did it, it's a little bit off because of the data, it's release year, but you can imagine it's for each genre, how much did it earn per year, okay? This is probably off. You can notice that 2016 is declining for all these. It's probably like we only have a subset of the data or something, right? If we see this through all of these, it's probably something to do with the data. But this is not bad. What I would do at this point, let's call this my grouped or sales per genre per year. And now what we can do is, I don't like working with these multi-indexes. So an easy way to fix this is just call .resetIndex, right? And now we're back to something like normal, right? We just have incremental values. So let's call this index sales. All right, that's fine. And then what's next? Next is to get to our growth rate. So let's do that now. So we will, to get to the growth rate, we can do this thing of basically do %% change. Okay, and let's just select global sales again. Okay, so you can see what's going on here. It's calculating the % change against the previous year, right? So that's why this one is up, I guess 2%, which seems about right. And then this row is down 20% or something like that, which also seems right. It's a significant decrease against the previous year. Sometimes these, year-to-year fluctuations, it could be more dramatic. We would expect like the longer the length of time, the more smooth these variations to be. So you can play with that. This method takes a periods. You can say periods equals 2, and then it will look back. It will compare this, for instance, against 2 years, 2 rows back, essentially. And that's all it's doing. It's literally just looking against two rows back. So that's why we have 2 NANs here, and now this negative 0.18 is comparing against this 122 here. All right, let's add this column. So this is % change. Let's add this column to this above data frame. Dot assign % change equals % change. And I can call % change in sales. And then let's call this sales with growth. Okay, let's look a little bit more than this. So you can see, right, each row is action 2012. It earned 122, whatever that is. And then we don't have any earlier data, right? And we're comparing 2 years back. So we finally get to here. We see 2014. It earned this amount, and it has a negative, right? This is actually less than it was 2 years before. One dangerous thing here is that it's like, how does this have a number? Or what it's doing is it's just going 2 years back, right? So it's comparing this versus this, right? So that's something so basically we don't want to use the first row, like any of the 2012 or any of the 2013, but 2014 is safe, right? We're comparing 2014 versus 2012. You can confirm that that's true for all of the categories, but I just having worked with this, I know that it is. So what we can do now is let's just say we just want to see, let's just select the year 2014, right? We can say what was the sales in 2014 for each genre, and how much did it grow in the past 2 years from 2014 to 2012. So the way to do that is just select where the year is 2014. So just do that, where the year equals 2014, and we'll say, sales growth 2014 data. Okay. Oh, and I'm doing this wrong. I need to select it, right? And not do that. Say that. Oops, I want to slice. Okay. So, right, we went from action for every year and the growth to just say, okay, let's just look at 2014 because this is the year that we know, right, the look back is within the same genre. So here you can see, now this is kind of what we want. For all these different genres, we have both the global sales and how much they made, right, the % change compared to 2 years before. Okay. There are different things you can do that, you can just like sort by this and see, okay, here's, the growth and which of these genres are growing the most. I think the main thing is there's kind of like two criteria that you would want to like focus in on. And there's this thing called a BCG chart, which I really like, that allows you to like think of both of these axes. What's the current sales for this year, and then what's the growth rate at the same time. And the way that we do this is you just take, I forget what I call it, sales growth 2014, and you just do a scatter plot where X is going to be the global sales, and Y, I guess in this case, will be the percent change sales. And then, so this is just a normal scatter plot. I can maybe plot this. Okay, so this is a scatter plot, and you can see there's no labels on this. So to add the labels, here I'm kind of capturing the plot, and then I'll say, okay, go through this data set, and for each of these, add text at this point. So this global sales is like my X value, and the percent change is the Y value, and this is where I want to put the text of the genre. So I broke it. It would be sales growth 2014. And I broke it again because it should be global sales, percent change sales. All right. So this is now, here's what you can kind of see is this is the sales in 2014, and this is the percent change in sales in 2014. So it actually, what we want ideally is genres that both have a high degree of sales and are growing and also have a high growth rate. And that would be things in this quadrant, right? Things in this quadrant are ones that have a high growth rate, right? This is the growth rate, but they don't currently have a lot of sales. So these are what's called like your question marks or whatever. Like you think they'll be big one day, but they're not quite there yet. This part would be like your stars, right? They're both like, they are currently big and they're growing, right? And then down here, these are things that fail on both counts, right? They're both don't have a high growth rate, and they're not currently profitable. So these are called like pets, right? Because like they're a pet project, I guess. And then these right here are more what are called like your cash cows, right? They are bringing in a steady stream of cash for you, but they are not growing. Okay, so Action, you can see, it's not like it has a low, right? It's basically flat at this point. But it is, you wouldn't want to kill it because it's your revenue stream. So, and you can see I just broke this, I just basically took this thing and I split it into these quadrants, right, of the question mark. Yeah, it doesn't zoom in well. But the question mark, right, these are ones that have a good growth rate but not as many high sales currently. The stars, right, these, we saw that this was kind of empty, and then we have these cash cows, right, that are essentially these, okay? And then you have the pets down here. So why is this useful? Well, if you are, right, looking to get into the video game business or trying to figure out how to develop your next game, right, like these will be things to watch, right? These things are growing. These, right? These are ones with like a higher growth rate, especially this fighting thing. Whereas, right, this one, like these may, have a large degree of current sales. So maybe even if this stays flat, it could still be, profitable potentially, right? And the other point is just this kind of plot. It's not just, we're doing it with growth rate and percent change in sales, right? Or sorry, the growth rate here and total sales and current sales here. But you can choose, this is a way to plot, things across multiple dimensions in general, right? So for example, like a typical one is just like low cost and high quality, right? Like if you're like looking to buy something, or like if you just think about like Yelp, right? Like I want 5 stars. That's like, $2 signs or something like that, right? So any kind of, you could just do this kind of sketch as long as you have like 2 axes, I guess, and then this third category. So, here, companies with high salaries and high benefits, or like have great health insurance, right? Or stock options or whatever. Right, so you can imagine plotting them out as a way to choose which ones are the best. Okay. So this is just a nice way to, like, another kind of broad sweep I would put this in, right? Maybe it's a little bit more work, but not too much more, right, to calculate growth rate. How's this feel? Good? Okay. All right.
I have a quick question, Jeff.
Sure.
So actually 2. One being, is this, we just went through the whole like ELT, ETL process and what that looks like. One is by the time we get here, are we at the end of that process, are you saying? Or is this like, am I observing the data? And once I do, I can figure out what data points maybe the company want. I don't know. And
Yeah,
like drop it in the database then.
yeah,
Yeah.
I get your question, I think. So, when would you want to do something like this? Um, so one, I'd say one is just remember, keep in mind that like there will be maybe different teams, right? So you might have data scientists who ideally are kind of like also providing some insight and saying, hey, we really need to start providing this kind of metric to our people, to like the analysts, etc. Because what I think is lots of times this kind of analysis, like here we have all the data, right? And we're taking this approach of whether we're data scientists or data analysts, like we don't know what we should track, like what the valuable data is. Okay. So it's more like when you find that out, right? That's going to inform your data dashboard of, okay, these are the tables and maybe how the data is coerced in order to track it. Now, right, because once I know, hey, like geography really matters a bunch in terms of predicting my sales, and that's how my data really varies. Like we want to then develop dashboards that really show that geographic breakdown and maybe gathers more data on that, et cetera, et cetera. So ideally, right, like this analysis informs like the development of the dashboards. Whether does that work in practice? I'd say in practice it's probably the case. I'd say most likely is the case. They just take a guess, and then as they go along and learn more, then they start saying, hey, we better start building this into the dashboard. We better start building this into the dashboard. But in terms of like, say you are working on a project or like going forward, yeah, I would recommend doing some of this, especially because you now can do it in a few hours, or maybe it'll take a couple days. Do this first to see where is the interesting data to plot. What are we should be making decisions based on. Because you don't want to get to the end of developing like all these dashboards and the data never changes, and it has nothing to do with what we're trying to optimize, right? Like that's where people are like, I'm looking at these charts and they tell me nothing, right? So generally, like we want things that one, like are predictive of our target, and two, we can actually change. You know what I mean? Like when is it valuable to know about geography? When we can determine like which stores to open and where to open stores and which stores to like shut down, right? Like when we can actually change it. If those stores are fixed, I don't know. Like maybe that's indicative. Maybe that's helpful, but probably more just of like where to market, or just to learn more about the customers, or how to market to them, or maybe we move online. But it's really when it aligns with things that you can change. Okay. Did you have another question, Christina?
Yeah. Follow up, or yeah, separate question. But I feel like, we're really harping on sort of take a step back and think about the actual data set and what seems interesting, and we're using these different functions to sort of help us with that, like build and print and whatnot. But I almost feel like, for me, I don't know if everybody feels this way too, but at this stage in the game, I'm almost not even familiar enough with pandas to know how to get the data to do what I want so I can see it.
Yeah.
So I'm kind of in this like middle ground of, do I focus on like how to even use this library versus like in an interview, will I even have these functions readily available? Should I be focusing on how to build those functions, or should I just sort of like get the concept of what we're trying to analyze, and then the syntax will come?
I see.
I feel like kind of everywhere.
That's
right
fair. I'd say like you can, so we basically build up the library in a single lesson, right? That building a library lesson. And so going back through that is okay. How would this come across like in an interview? Through a take, in my experience, only through a take home. I think maybe that's not true. Like once it was more for like a day long kind of interview, but I don't want like I think the way I saw you actually like working through the library of like asking ChatGPT and things like that. I think that's fine. Like or like I don't want to spend too much on just like the tooling of pandas, but rather you can look at exact what we're using, which is like group by, because pandas can really just do so much, and ultimately then it's not it's not what people really are assessing you. It's a means to an end. So I would say like if you are confused with how to do this, just remember we're really only using a few pandas function, right? Like you can kind of go back through that material if you'd like, or look at the building a library. That's kind of where I would start. Look at that lesson again and then see if things clear up for you. But what I would focus on is more after you feel okay with that, like the emphasis of this is really like the approach, I'd say, regardless of the tool that you're using. Yeah.
I think I might have missed something from Christina's first question, but so you're basically saying that this is happening after everything has been run through the pipeline?
Well, ideally not. Before. Ideally,
Okay.
it's before. I mean, once the data is clean, more or less. But I think the truth is that, yeah, you do upfront analysis, but you can't spend forever, figuring it out. Like, you have to start providing people with some information, right? So, that's why we are taking, like, we're kind of providing, like, hey, when you do these steps, like, that's your first pass, and, like, you're ready to start thinking, as we'll see soon, like you're ready to start thinking about how do you present this information, right? And so like you do this first pass, eventually you'll start developing a dashboard, and the truth is that it's iterative, right? Like you'll develop the dashboard, you'll learn more about the business will learn more, the COO will tell you, hey, why are we not tracking this, right? The data scientist will say, hey, shoot, this is super predictive, right? And so as time goes on, these dashboards will be updated, right, as you learn more about what data is valuable and etc. There's a classic, I forget who said it, Edward Codd or something like that. It's all models are wrong, but some are useful. Okay, so like in other words, like these, like the data that you gather, like in saying, hey, this predicts sales, all of them are that's never the full story, right? Like the data analysis is only people are choosing things because whatever, like for irrational reasons all the time. So the data is never going to be fully predictive, but can it provide some value to you? Are you at the point where, okay, this can start to provide some value, it's ready to develop? But doing some, so you're doing some of this upfront work, obviously I would recommend it because, now you know what to plot and how to tell this story better. And we'll get to data storytelling, but how to tell that story better. Okay. So yeah, what I'm trying to do is hopefully in just a few, if you're given a take home or if you're given a project like this, how to get started in a way that, and I think you all are getting the hang of it, in a way that you're not doing these going down rabbit holes, et cetera, right? Like applying the 80-20 rule, take the broad sweep. Eventually we'll move more into this, provide the actual answer as to just like, kind of useful plots, etc. And also looking at the representativeness of the data we talked about. Okay. I think let's stop there.